The next type of reaction that we want to look at after double replacement and precipitation is another type of double replacement reaction known as an acid-base reaction. Before we can get into the details of acid-base reactions, though, let's define the terms acid and base. There are two major categories of definitions for acids and bases, two different definitions by different scientists. One is known as the Bronsted-Lowry definition. We'll learn that definition when we cover acids and bases in much more detail in the spring. The other one is known as the Arrhenius definition. This definition looks at what happens when the substance dissolves in water, when it's an aqueous compound. An acid, under this definition, is defined as a compound that produces H+ ions when put into solution. So it'll separate to form that H+ ion anytime it goes into solution. And a base is a compound that produces OH- ions when in solution. So we have H+ ions in solution for acids, OH- ions in solution for bases. This definition works really well for a lot of things we're going to look at. It's a little bit too simplified for some cases that we're going to see, and that's where the Bronsted-Lowry definition in the spring will come in to give us a little bit broader definition of acids and bases. In an acid and base reaction, we have an acid reacting with a base. You're always going to have the H+ ion, you're always going to have the OH- ion. When those two come together, they're going to form H2O. H2O is not going to be aqueous. You're not really going to have water dissolved in water. You can form these two ions, but H2O we're generally going to refer to as a liquid. So here we have two aqueous coming together to form the liquid, H+ plus OH- forming H2O. The other product is always referred to as our ionic salt. And depending on what the cation was with hydroxide and the anion with hydrogen will determine what that salt happens to be. So let's look at some examples of these. HCl plus RbOH. HCl, hydrochloric acid, rubidium hydroxide. We're going to switch partners, so our products will be H2O, liquid, and RbCl. RbCl, we know chlorine is aqueous with everything other than lead, silver, mercury. So this will be our ionic salt. This is our water. You would see if we wrote the complete ionic equation, we'd have H+ aqueous plus Cl- aqueous forms Rb plus aqueous plus OH- aqueous form H2O liquid, Rb plus aqueous, and Cl- aqueous. Cancel out the spectator ions and you get that reaction we saw before for the net ionic equation. The other cases here, pretty straightforward. HClO4, the products will be H2O liquid, and NaClO4 aqueous. Anything with sodium is always aqueous. Here are products H2O liquid and NaBr, which is aqueous. All of them will have the same net ionic equation. So acid-base reactions, the key thing is to recognize what an acid is and what a base is. All of these compounds starting with hydrogen, we learned that when we were naming acids, would separate to form H+ ions, so there would be acids under the definition. All of the second reactants here form hydroxide ions in solution, so they would be bases, and our products are water and our ionic salt.